Welcome. Today I am continuing same moment of inertia calculation. I wrote title dedicated to steel structures. Today's is part B. See, today part B. Therefore, remember, if anybody suddenly come to this class, you will have difficulties. You have to start from part A. Part A, part B, in the same order you have to start. Next class I will upload part C. Then also, if anybody is new, I will tell start from part A. Because all the concept, what is a rolled section, what are these properties, all explained there. I told further I am not telling. As usual, meant for those who are serious about studying. Okay. 88. See, the cross section of a steel beam, or it can be a column also, but does not matter to you know. The cross section consists of a RSJ. I told what is RSJ in the last class. ISMB 500 with the two flange plates 400 mm by 20 mm, comma, one on each flange. Means total there are two flange plates. Among the two flange plates, one plate is on each flange. As shown, see, line diagram. This is the I section, see, this is the I section, that is RSJ. These are the two plates. Find moment of inertia about centroidal axis. In the question only given, properties of RSJ, see, I gave all the properties. See, these all I explained last time. Go back to last class, study and come back. Okay, this is the question here. Now see, so many things are given. Some of them are not required. So when I write the properties, when I solve this, see, this is a question. You should copy the question as it is. Don't write anything. First you copy the question, then you write solution. At that time, see, draw a neat sketch. See, I section. See, this is ISMB 500. Properties, they told breadth of flange is 180. You can see here. The thickness of flange and thickness of web. This thickness and this thickness, this class not required. If required, you write. So I know it is not required. Okay, then the total area is 110. I given the area here. Oh, no, it is actually, I changed the I section. It is actually some other I section. 11074. Because first I took some other I section. I took ISMB 300, I think. Then I changed to ISMB 500. So that's why I forgot to change. Okay, in the question given 11074 mm square. Also they told I about this axis is so and so. I about this axis given in the question. See, this is called H. Remember, this H is nothing but that number only. That is 500. Okay, 500 here. The plates are 400 by 20. See, this width of flange is 180. Plate width is 400. So plate will come beyond the flanges. Now write a neat section. Neat sketch you write. See, I wrote the I section as much neatly as possible. Too much decoration is not required. You write neatly. Now see, divide into three parts. Upper plate part 1, lower plate part 2. Why? Because you can make into 2. Upper plate I will take part 1, lower plate I will take part 2, full I section I will take part 3. You can write it. Write all those things. Okay, then now start calculation. I will remove this one now. Next question I will put once again properties. Okay. Now, next is 89. I will forget that one. I will make a note somewhere here. Next 89. Okay, now, first, always make a practice. See, one more thing now. See, this is 500. 20 and 20, 40. Total 540. Okay, now, they want moment of inertia about x, x, y, y. Make a note here. This I section is perfectly symmetrical about both x, x and y, y. See, last time question, only one plate was there. This is not there. So, YY was symmetrical there, but XX we located. This time no, you should write due to symmetry, see, perfect symmetry, your x-axis will exactly pass here. See, this is x-axis axis and this is your y-y axis. You make a note through center of the web, it will come this way. See, it will pass through G3. G3 is the center of the web. Okay, then it will come and pass to G2. This is your G2. I wrote here G2. Partially rubbed now, I will change it. Actually not required because we are making into 2. G2. Okay. X-axis and Y-Y. Now, always make a practice first to find total area, right here. Total area A equal to, see, area of the plate, 400 into 20. There is an identical plate here, same, multiply by 2, plus area of this RSJ is here, 11074. 11074 is the area. See, I will write here. Next time I won't write. This is for 1. This is for 2. Identical to 1. This is for 3. Okay, write the answer. Whatever you got, write the area. Then write I about x-axis. Before that, write the usual statement. Now I will not write. Those who are lazy and cannot write and that doubt, confusion, let them get confused. Question number 88. I wrote it more than each question. I was telling it 10-15 times. I about any axis equal to ig plus a square. Write everything. Start first. Come here. I about its own center order axis parallel to x-axis. It is 400 into 20 cube by 12. 400 into 20 cube divided by 12 is Ig plus area is 400 into 20 is the area multiplied by space. I forgot here. You should write what is this distance. When total is 540, extreme fiber, both of them will be, see, I do one thing, x-axis, x-axis. From here to here is 270. This also is 270. Enter here. 270. This is your x-axis. So here space is not there. Into, see, space is not there. I write here. Into from centroid G1 to x-axis. This distance square. 270 minus 20 by 2 whole square. This is I about x-axis. Okay, I think I got problem here because, okay, no, I write here because it will not be clear here. Okay, I write here so that no space problem. See, I about x-axis. Into 2 there is no place. Okay, start. I about its own center of axis. 400 into 20 cube divided by 12 Ig. Oh, so light problem, 1 minute. Some loose connection in the light. Okay. I about its own axis plus area 400 into 20 is the area multiplied by, see here, multiplied by from centroid G1 to x-axis. See, with respect to x-axis, G1 lies outside. It is not, see, it is outside. 270, these are all so simple. 270 minus 20 by 2 whole square. This will give I about x-axis for which one? For 1. See, this everything is for 1. For 1. Now, for 2, see, identical answer. Once again, same Ig, same h square. See, 1 and 2 both are symmetrically placed with respect to x-axis. So, don't waste time. Multiply by 2. Right here. This is for your part 2 plus I about x-axis for this RSJ. See, first about its own center order axis. See, this axis. See, this axis, that axis I is here. 45218.3 10 to the power 4 Ig plus area 11074 is the area into from centroid G3 to XX. Centroid G3 lies in XX, therefore 0 square. This all told thousands of times. 0 square. That's all. Make a note here. This is for 3. See? This is for 3. Write whatever answer you got. Then, okay, IYY, I write here. Actually, next you require IYY. See here. IYY. Okay, I can write here only, no problem. Okay, space. Okay, I will write here IYY. Next time I will lift the section slightly. Start. I about YY for this plate. First about rectangle, its own centroidal axis, parallel to YY, same axis. 20 into 400 cube by 12. 20 into 400 cube by 12. Ig plus area. 20 into 400 is the area. Hot 420 into from centroid G1 to YY. Oh, centroid G1 lies in YY, therefore 0 square. Then whatever you get, multiply by 2. Right here. This is the same way. You should write, if you are interested, right here. This is for 1, this is to take care of 2. If you cannot write, leave it. Don't do anything then. Plus. I about YY for RSJ. See. First about its own centroidal axis, this axis. That I is here. 1369.8 10 to the power 4 plus area is 11074 is the area into once again centroid G3 lies in YY into 0 square. Over. Calculate and write the answer. Then if it is a beam question, you find section modulus, and if it is a column question, you find radius of gyration. You continue there. Our purpose in the class is over. That is finding moment of inertia. So, last class I solved RSJ with the flange plate on one side only. Today RSJ with the flange plate both sides. Actually both sides are easy because why? Both symmetrical. If the flange plate is only on one side, see last class, YY was symmetrical, but XX is not symmetrical. So there, extra work, you have to do Y bar calculation. Here, Y bar is not there. Okay, now I'll go for question number 89. I'll prepare the question to save the time. Next, question 89. I'll put the number. No, 89. Okay. Okay. I write a full question, solve, and then start. Question 89. This is very popular in steel columns. Actually, I wrote roughly here only line diagram. See, sometimes what happens is it won't come very clearly. Okay. The cross section of a column consists of two identical RSJs, ISHB 350. You don't bother about what is the ISHB, what is ISMB. That number is required for you. Okay. Placed as shown means see, in construction, one I section here, one more I section here. They are actually finally joined by lacing or battening. That all comes in steel structures. Okay, now, see, they told that, see, this is 130 given, be careful. This 130 is the clear distance, see, or instead of giving in the sketch 130, they can mention what? At a clear distance of 130 mm between them. See, clear distance, see, this is a clear distance. Next question, I will use centered center. Okay. Find moment of inertia about centroidal axis. Okay. Properties for each RSJ is given here. See, I told property, I changed it. This is a property for ISHB 350, breadth of flange, depth is see, ISHB 350 means depth is 350, area IXX, IYY given in the question. Okay, start. Write the cross section. Neatly write the cross section. I am saving some time now. Okay. Write the neat cross section. Okay. All dimensions are in millimeter. As see, this is our 1 unit. See, complete I section 1 unit, complete I section 2 unit. Now for this unit 1, centroid is here. Centroid is here. See this G. Now here there is perfect symmetry. You can do one thing. You can make a note. Perfect symmetry. So before that one, see, tell me the overall dimension. Overall depth is, see, this is this H 350. Okay. Overall width. Now remember, now breadth of flange is required. Now breadth of flange is required because, see, this is breadth of flange. How much? 250. 250 plus 130 plus 250, it is 630. So you can make a small note there. How this 630 came? That came 250 multiplied by 2. What is 250? That breadth of flange. See, that breadth of flange here. Breadth of flange, 2 plus another 130. Just a minute. Did I write 2 upper side? No, clear, visible. Okay. Should be visible for you. How you got 630? See here. 250 into 2, so plus the gap is 130. That's how you got 630 millimeter. Okay, now YY will come exactly in between. If it is 630, half of 630, half of 630. XX will come here. If it is 350, 175, 175. Always do one thing. First find area. Just to make a area. See, area of 1 RSJ, 8591. 8591 area multiplied by 2. See, 8591 is one of the areas multiplied by 2. You get the answer, area. Write the answer here. Whatever is your area. Little below I will write. To save the time, area. See, 8591 into 2. You write here. 8591 is for 1. Into 2 identical. Okay, write the answer. You can make here. This is for 2. Then I about XX axis. Start. Any one I section, see here. I about its own centroidal axis. It is nothing but this axis. 19157, 19159. Okay, 19159.7 10 to the power 4 Ig plus area is 8591 is the area into from centroid G1 to XX. Oh, centroid G1 lies in XX, therefore into 0 square. Now everything multiply by 2. Y2, now you should write if you want. Identical for this one, see, second one. So that's why into 2. Okay, over. I about YY. I about YY. Start. First. After 2, anyone. First, I about anyone. Its own centroidal axis. See here. This axis. That is nothing but 2451.4. 2451.4 10 to the power 4 is its own Ig plus area. Where is area? 8591 is the area into from centroid G1 to YY. See this distance square. See from YY, centroid G1 is outside YY into this distance square is, this is breadth of flange is 250. This is 250 means this is 250 by 2 into, see, 250 by 2, I write neatly. It's very important term for channel section, okay, into 250 by 2 is from here to here, plus this is 130 means exactly midpoint, plus 130 by 2. 130 by 2, that one whole square. Okay. Then this is for this one. Multiply by identical 2 for taking care of that one. Write the answer. Now, or you can do one thing. See, from centroid G1 to YY, this distance square, I told you 250 by 2 plus 130 by 2. Or you can make a note here. Or 315. See, you can make a note here. Or it is 315 minus half of 250. That also will do. That one to be squared. Both are identical. Now, question 89 over. Now, today's last question. For a class, not more than 3 questions. Okay. Question number 90. Now, what I will do now is, some time I will save for myself now. Question number 90. Okay. Now, the cross section of a column consists of 2 identical RSJs. Just to save that, okay, I will change it. ISHB 400 placed as shown below. Now this time I am giving what? See, I am giving this way. 250 plus 250, 125, 125 is 250. 250 plus around 160. 250, 160 is 410. Okay. 410. Or, see, width below, not over 400. See, identical, I put sketch once again. See, 2 identical RSJs, ISHB 400 with, okay, with 2 flange plates of 1 minute. 250 plus 250. How much I am taking center? I decided to 250 plus 150. 160. 160 plus 250 is 0, 1. 410. 410 means 410 plus another 250. 0, 6, 660. 2 flange plates of 700 mm by 16 mm, comma, 1 on each flange. It's a very popular question. 1 on each flange as shown below. See, 1 I section here, 1 I section here, 1 more I section here, and then 1 plate here, 1 more plate here. And in the question it is given, see, from center here to center here is 250, this is 250, 250 plus 160, 250, 410, okay, 410, I write it below, 410, okay, 410 given, okay, I'll do one thing, why confusion, okay, neatly, 410, to save the time, find, why waste time, find IXX and IYY, that's all, no statement, IXX and IYY. And for the RSJ, properties are given here. I'll change it. I have to refer the steel table or handbook and give it. Okay. I'll give the question. First I'll write from the handbook, I'll copy the values, then I'll give the question for you. Okay. I'll make ready. Now, question 90, I will read the question once again. The cross-section of a column consists of 2 identical RSJs, ISHB 400, with the 2 flange plates, 700 mm by 16 mm, on one on each flange, comma, see, 1 on each flange, 1 on each flange as shown below. Okay. Now, two I sections are placed here. This time, last time, see, if you remember last time, this clear distance was given. So what you have done, this clear distance plus this half of flange width will give center. But this time, center given. Or in the question they can give two identical RSJs, ISHP 400 placed at, see last time clear, this time placed at 410 mm center. See, from center to center here, 410 mm. Okay, this is cross section, you write all in millimeter. Okay. Plate is 700 by how much? 16. Okay. Now, find, as usual now, find Ix, Iy. Properties I wrote here. Okay. Breadth of flange, area, Ixx, Iyy given in the question. Then, write a neat sketch here. See, now 1 minute here. See, this is 250. This is 250. 250 plus 250 is, or 1 minute, this is 410. Okay. This is 410 plus half of 250 plus half of 250 will give you information for you, that's all. In steel it's important. See, this 410 is center plus half of 250 plus half of 250. 410 plus 250 by first is 410 plus 250 is, why calculate problem? 410 plus 250 is 660. So the plate will come slightly outside. Okay. How much outside? Not required. 700 by 16. Okay. Now, correctly mark. See, this RSJ will take 1, this RSJ 2, this rectangle 3, this rectangle 4. Properties are there. Now, if you want one thing, clear distance is not required now. The clear distance is not required. Or see here, if you want the clear distance by chance, see, it is not required. From 410, subtract 250 by 2, subtract 250 by 2. So from 410 minus 250 by 2, 2 times, will give 160. Or in the question, if they give clear distance 160, see, in the question if they give clear 160, mark 160 here, then 160 plus half of 250 plus half of 250, you will get 410. See, this 410 is center. Okay. Now, this is 16. This is 16. So 16 plus 16, 32 plus 400 is 432. Full 700. Okay, mark XXYY. See, again write perfectly symmetrical. So, see, this is your XX axis. XX axis. If that is 432, this will be 216 and 216, half of. This is 700 means your YY will come here. See, this is not required. YY will come here. YY. Distance will be exactly, this is YY, total 700. So from extreme here, it will be 350, 350. 350, 350. Okay, now start. Total area first. 1 I section, 10466. 10466 is area of this RSJ. Same here, multiply by 2. You should write here. This is for 1, this 2 is for taking care of that RSJ, second RSJ. Now plus 700 into 16 is area for 3. Identical here, multiply by 2. Right here, this is for 3, multiplying by 2 is for taking care of 4. You should write those things. Okay, start. Now, IXX. Before that, you should write usual story. Start. I about its own centroidal axis, this axis. That is there. 28823, 0.5, 10 to the power 4 is Ig plus area. Area is 10466 is the area into centroid G1 lies in XX axis, therefore into 0 square. 0 square. This is for 1 right here, for 1. Identical for 2, therefore multiply by 2 outside, plus Start. Plate. I about its own centroidal axis parallel to x-axis. 700 into 16 cube by 12. 700 into 16 cube by 12 Ig plus area. 700 into 16 is the area into from centroid G3 to x-axis. It is not lying in x-axis. This distance square, that is 216 minus half of 16 whole square. Whatever you get, multiply by 2. 1 minute. Okay, correctly. I read the edge of the board. Okay, multiply by 2, calculate and write whatever answer you got. Next, I about YY. Start. First here, I about its own YY axis. Here, its own centroidal axis. That is this axis. 2783 10 to the power 4. 2783 10 to the power 4 is Ig plus area is 10466 is the area into, see, into from centroid to YY, this distance square is exactly half of 410. 410 by 2 whole square over into 2. This is for 1, multiply by 2. By chance, if you use 350, what you have to do? 350 minus the small distance. That small distance is, I told you, 700, and I told you already, from here to here is 700 minus 250 minus 700 minus 410 minus 250 by 2. 250 by 2 is how much? 700 minus 410 minus 250 is 40. If that is 40, this will be 20 mm. Okay. Then you can also do I about its own axis plus this distance square is 350 minus 20 minus 250 by 2. But actually, why unnecessarily? If they give center, directly you can get the answer. Okay, into 2. Plus, for plate, I about its own centroidal axis. Oh, it lies in YY. So, 16 into 700 cube by 12. 12. Plus area. Area is 700 into 16 is the area into 0 square. If anybody got difficulty, why 0 square, better stop learning from me right now only. High time, stop continuing. If after multiply by 2 for identical here. If after so many explanations, if someone would tell, sir, why 0 square, sir? No reason. No, I won't talk. Okay. This question is over. Now, one small note if you want. See, one small note you make. By chance, if the question given is cross-section, make a note. By chance, if the question given is 2 RSJs and 2 flange plates 700 by 8 mm, then on each flange, that means last time 2 plates of 700 by 16, 1 on each flange. This time on each flange means, see, 1 plate here, 1 more plate here. Then the question is same because in that case, see, there is 2 plates here, 700 by 16. You can do one thing, see, you can do one thing, light, divide into parts here. 2 plates are there. This is 8, this is 8. So this total becomes 16. Here also, this is 8. This also 8, 16. Then do one thing, the 2 plates together, you take a single rectangle of thickness 16 and answer will be same. Suppose they give 2 plates of 700 by 10 mm, this will become 20, this will become 20. If they give 2 plates of 700 by 16 mm, 32 and 32. Solve the question. Okay, now, sometimes some people may comment now, he changed the question, but see, he forgot to change the width of 250 mm. Not changed because I know ISHB 250, ISHB 300, ISHB 350, ISHB 400, ISHB 450, all those ISHB series, depth will keep. See, last time I took 350, now I took 400, but for all of them, width of flange is same. I know it is 250 because I know it. That's why I not changed. Somebody may tell, he forgot to change the width of flange. I not change the width. It is same width. Go and check the steel table or IS handbook. Width of flange is same. Okay, leave it. Now, over. Now, next class, I will go for some more questions. See here. All important questions. I will continue first I section. I section, first of all, I will take a case of a special I section. I section, two I sections. One here, one more here side by side. It is actually used somewhere. Two, one placed above other one. Okay, this I will take up. Then I will take one I section here. See? One more I section here. This way, turn perpendicular. Then one more I section here. This way. Then these two I will maintain same. This will make different. These are when the column is required to support heavy load, multiple I section is used. It's our advantage. These I will cover, and then two RSJs. I will think of if something more is there when RSJ is used. Once the RSJ is over, then I will go for channel section. See, two channel placed back to back without flange plates. Then two channel placed back to back with the flange plate. Once only on one side, then on both sides. Then two channels placed face to face without plate, then with the plate. Then four angles at the four corners. This is a very popular column cross section. This way. First I will take four equal angles. Then I will take four unequal angles. And then I will take again four unequal angles when the orientation here is opposite to handbook. I will explain at that time. Then property XX means it is YY here. Property YY there is XX here. This all I will explain. Then lastly, one I section and a turned channel here. Maybe with a plate here. This is actually for gantry girder. Beam gantry girder. Sufficient. Once that much is over, this moment of inertia part for steel structures will be over. By that time, another 4-5 classes are over. Then I will decide, shall I start exercise problems or not? I think so many questions are solved. Still, maybe I will prepare some exercise questions, some easy questions with answer. I will decide at that time. Already question number 90 now. It is not to take it to 100. When I take all of this one, it will cross 100. Okay. Next class, we will go for these special I sections, and any other RSJ if required, I will do it. Then I will go for channels, angles, etc. So that when you study steel structures, you have no difficulty for moment of inertia, whether it is a cross section of a beam or a girder or cross section of a column or a gantry girder, there is no problem. Okay. We will meet next class. Thank you.